नमस्कार, आप सभी का बहुत बहुत स्वागत है। आप देख रहे हैं PMeVIDYA चैनल नंबर 12 और NCERT का ऑफिशियल यूट्यूब चैनल। आप सभी के साथ हूं मैं रेणु भट्ट। आप सभी का स्वागत करती हूं इस लाइव फोन इन सेशन में। और आज के इस सेशन में हम बात करने वाले हैं मैथमेटिक्स के 12th स्टैंडर्ड के स्टूडेंट्स के लिए। एंड द टॉपिक फॉर दिस सेशन इज इंटीग्रेशन पार्ट 4। हम पार्ट 4 पे बात करने वाले हैं। पार्ट 1st, 2nd एंड 3rd ऑलरेडी हम कर चुके हैं। यू हैव लर्न अ लॉट अबाउट इंटीग्रेशन। अगर आपको देखना है वो पार्ट्स या तो कुछ चीज़ आपकी मिस हो गई है तो आप हमारे YouTube चैनल पर जा सकते हैं और उसे एक्सप्लोर कर सकते हैं। और हम आपको बता दें कि आप हमारे साथ हमारे विशेषज्ञ जुड़ चुके हैं। हमारे एक्सपर्ट से हम मिलते हैं। आप हैं मिस्टर राहुल सोफात, लेक्चरर मैथमेटिक्स फ्रॉम एयरफोर्स गोल्डन जुबली इंस्टीट्यूट, सुब्रतो पार्क, न्यू दिल्ली। वेरी वार्म वेलकम सर।
Thank you.
And before we begin this session, but let me give some certain information to all our viewers and learners. अगर आप हम इस लाइव फोनिंग सेशन में आप पार्टिसिपेट करना चाहते हैं, जो कि हम आपसे आशा करते हैं कि आप करेंगे, तो आप हमें कॉल कर सकते हैं, आप हमें ईमेल कर सकते हैं और आप हमें मैसेज भी कर सकते हैं। आप हमें कॉल करेंगे हमारे टेलीफोन नंबर पर जो है 8800440559, or you can either mail us on our email address, that is dth.class12@ciet.nic.in। और अगर आप हमसे लाइव स्ट्रीमिंग के थ्रू जुड़े हैं यानी कि यूट्यूब चैनल पर हैं तो गो टू द लाइव चैट बॉक्स एंड ड्रॉप योर कमेंट आउट देयर। ये तीनों ही तरीकों से आप हमसे जुड़ सकते हैं और अपनी सभी बात, अपनी सभी क्वेरीज हमारे विशेषज्ञ तक यानी हमारे एक्सपर्ट तक आप पहुंचा सकते हैं। वी आर एक्सपेक्टिंग योर पार्टिसिपेशन, तो आप ज़रूर पार्टिसिपेट करें। एंड सर, हम अब विदाउट वेस्टिंग मच ऑफ आवर टाइम हम क्विकली ये सेशन शुरू करते हैं। But before we begin this session, so shall we begin this session with the brief recap of the previous one?
Yeah, of course. Good afternoon, everyone. In the previous session, we have in integration part 3, we have covered certain topics of integration. 6 special integrals we started, and then after 6 special integrals, we practiced some questions of integration by partial fractions. And then we ended with integration by parts. Only few questions of integration by parts we had taken in the previous session. So I'll be continuing with integration by parts and then moving further ahead.
So sir, what exactly you have for our learner in this specific session, sir?
Yeah, actually it is a continuation of integration. It is the session 4 of integration. So now in this unit or session we will be doing integration by parts, one special case of integration by parts, and then we will be moving to 3 more integrals. Okay. And later on we will even introduce definite integral and some properties of definite integral.
Sure sir, so shall we begin?
Yeah,
sure sir, please continue.
Now students, as you have already learnt in the previous session, that in integration by parts we have got product of 2 functions, and all of you know that
yes,
in
sir.
integration, all of you know that in integration by parts we don't just integrate the product of the 2 functions, we don't just separately integrate and multiply. What I'm trying to say is, if you have to integrate, let us say, product of 2 functions, is it equal to product of their individual integrals? No. A rule is followed, and that rule is integration by parts. Now this states that if you have product of 2 functions, here we are taking fx multiplied by g dash x, right? Now what is this rule? The rule says you take the first function as it is, multiply by the integral of the second. This is first function, this is second function. The order in which they are written are the order of these 2 functions. The first function is fx here, the second function is g dash x. Now you know the formula is this: first function fx comes as it is, it's written here, first function as it is. Now integral of second, this is the integral of second which is being represented in this box. Integral of second I will write here. So first function as it is, integral of second minus integral derivative of the first function. Now what is our first function? Fx. If you differentiate this function fx, you will get f dash x. So this is derivative of the first function multiplied by the integral of second. And here I have written integral of second, the same thing will come inside the integral. So basically what you have to remember is this rule. Again I am repeating the rule, we have already done this earlier also. First function as it is, integral of the second function minus integral Now derivative of first function, you can even take this as a first function. So derivative of first function is f dash x multiplied by integral of second. So this comes as it is. So I hope this is clear to all the students. This rule we apply when we integrate two functions. Like suppose we have product of algebraic and trigonometric function, or we have to integrate ex multiplied by x square. So in all these types of functions, we apply this formula. Now next is, I am taking a particular question which is based on integration by parts. See, now we have x multiplied by cos inverse x dx. There are two different functions. You know, first one, these functions are algebraic and inverse function, inverse trigonometric and algebraic. And you know, we don't always take the order in which they are coming. One of them is first function, the other is second function. And generally the order of preference is I late. First inverse, then logarithmic, then algebraic, and then trigonometric, and then finally exponential. Now here, because if in I late, inverse comes first, I will take this cos inverse x as first function. After that, the second function here is algebraic. Now the formula which we have I have told you, will apply here. First function cos inverse x as it is, integral of second. Now integral of second function, you know, integral of x is x squared by 2 minus integral derivative of first. So derivative of cos inverse x is minus 1 upon 1 minus x square radical sign, square root of this, and derivative of first, integral of second. And what is integral of second? X square by 2. Now if you simplify this, the second part of this, the second term is, we have to integrate x square upon square root of 1 minus x square dx. Again, we are in a fix. What to do here? Now, it is not an easily integrable function. So what I do is, I am substituting this particular integral as I1. Here, what is I1? I1 is integral of x square upon square root of 1 minus x square, and I will separately integrate this. I will find out its integral, and then I will substitute back in the equation 1. Right? Is that clear to you? Because when I am applying by parts, I am not able to get the answer in one go. Again, I am obtaining an integral. Now, how to integrate this? This integral, I will integrate with the help of substitution. What is the substitution? The substitution is x equal to cos theta. Whenever you have square root of 1 minus x square or square root of a square minus x square, our substitution is either a sin theta or a cos theta. Here in this case, I am substituting x equal to cos theta. Dx is equal to minus sin theta d theta. We differentiate x, that is 1 dx. Derivative of cos theta is minus sin theta into d theta. And then when I substitute here, x square becomes cos square theta. 1 minus cos square theta is sin square theta. On taking the square root, I will get sin theta. And value of dx, this dx is minus sin theta d theta. On simplifying this, I am getting minus, which I can take outside because multiplicative constant can be taken outside the integral sign, and I am obtaining cos square theta here. And you know, cos square theta is 1 plus cos 2 theta by 2. These formulas, half angle formulas, you remember. So 1 plus cos 2 theta by 2, and then half you take outside. Integral of 1 is theta. Integral of cos 2 theta is sin 2 theta by 2 plus c. And then the initial question was in x. So our final answer should also be in the same variable x. Now, cos theta is x. What will be theta from here? Theta will be cos inverse x. So in place of theta, I will be writing cos inverse x. And what about sin 2 theta? All of you know, remember the formula of sin 2 theta? It is 2 sin theta cos theta. So 2 will cancel. I will be left with sin theta cos theta. And then sin theta is square root of 1 minus x square, and cos theta is x. So finally, I am substituting this as I1 and solving this integral, which I will substitute back in the first equation. If you look at the previous slide, here I wrote this equation as 1, and this integral I1 I have to substitute here. So in the next step, this integral is continued, and its value of this integral I substitute in the first equation to obtain the answer. I hope this is clear to you. So sometimes, just by applying integration by parts, we don't get the answer in that very same step. Suppose we are getting some integral, like in this case, we were getting this integral, So that I am separately writing as I1 and then integrating it, and then finally whatever the integral comes, I am substituting back in the original equation where I left. I hope this is clear to you.
Yes, sir.
Yeah. Next is, again I am taking one more question, and these are some special questions of integration. So you know, integration by parts, generally if you apply integration by part once or twice, you get the answer. But here in this case, see the nature of these functions. I am integrating product of Ex multiplied by sine 2x. So the first function is sine 2x and the second function is e raised to power x. Now how I am finding out which is the first function? Because inverse, inverse, logarithmic, algebraic, trigonometric and then exponential. So trigonometric I am taking first and then exponential I am taking as second function. Now just see along with me how I am applying integration by parts. First function as it is, sine 2x comes as it is. Integral of second, integral of ex is ex only. You know that integral of second function, ex का integral ex होता है, minus integral derivative of first. What is derivative of sine 2x? Derivative of sine 2x is cos 2x minus cos 2x into 2, right? Again I am repeating, derivative of sine 2x is cos 2x multiplied by 2. Integral of second is ex. I hope it is clear. It is simple application of integration by parts. First function as it is, integral second minus integral, derivative of first, derivative of sine 2x is cos 2x multiplied by 2, integral second is ex. Now again I realize that I am not able to decompose the function so that it can be integrated easily. After applying integration by parts, you will find that again we have product of two factors. Instead of sine 2x multiplied by ex, I am having cos 2x multiplied by ex. So I am just repeating the procedure again, integrating by parts. First function as it is, integral second minus integral, derivative of cos 2x is minus 2 sine 2x, integral of second ex, I am just writing it as it is here, and then I realize that I am getting the same integral I started with. After applying integration by parts twice, I will find I am getting integral of ex sine 2x. Ex sine 2x was previous our original question, and that we have taken equal to I. So here this coefficient of I will be minus 4, because when you will multiply this minus into minus is plus, into minus is minus 4, and this whole integral I will write as I, because initially I have assumed this to be I. So these type of questions are known as, they are based on the concept of method of transposition. I am starting with the integral, at some stage I get the same integral back. So this minus 4i, if I shift to the other left hand side, I will get 5i, and then I will obtain the value of the integral. So integral I is equal to ex by 5 sine 2x minus 2 cos 2x plus c. So this is another special type of question which is based on integration by parts.
Right. So here could you please explain what are the application of integrations?
Yeah, actually, you know, in the next chapter we will see that once we are through this, that integration has a very important application. We can find area of the area bounded between some curves. Area below the curve, above the x-axis, it can be easily be found using integration. So those things we'll learn in our next chapter, and today also later in the class I'll define how we can find the area using integration. And later on, when you do your senior classes in your college, you will see that in advanced calculus we can even find volume of a three-dimensional solid using integration. So these concepts are very important. They can, in your 12th class, you will see it is helpful in finding out the area bounded by the curve above the x-axis, and later on you will also see that it can be used to find the volume.
Right.
Now, integration, another type I am taking which is based on integration by parts. This is how to integrate e raised to power x, fx plus f dash x dx. Now, these type of questions are very simple. What you have to do is, first you should identify that the question either is in this form or it can be put in this form. Sometimes to look at the question, you will not be able to realize that this function fx plus f dash will not be given like this. So you have to split the two functions, or using trigonometric manipulation, you have to convert it into this form. And once you have this in this form fx plus f dash x, then you separate the two integrals, ex fx and ex f dash x. So we have got two integrals. The second integral, which contains f dash x, you keep as it is. Nothing is to be done in this second integral, which is given in the box. The first one, which contains the function fx, I will expand it by parts. So exponential is always taken as the second function. So first function fx, integral of second ex, you know integral of ex is ex, minus integral, what is derivative of first function? Derivative of fx is f dash x, integral second, and children, you know integral of ex is ex. So now here you will realize that these two, the last two integrals, will cancel out each other. So this is minus and this is plus, and the same integral is coming. Minus f dash x ex dx plus integral ex f dash x x. So both of them will cancel out. So this will cancel with this, and you will obtain ex fx plus c as the answer. So this is a general type. It is a formula, and I'll just discuss few questions based on this.
Right.
I hope students, it is clear to you. If you have any query, you can post it, and ma'am will convey your query or question to me. I'll clear your doubts.
Sure, sir. So we have joined by so many viewers and we are getting so many comments. I would request my viewers to ask only relevant questions, sir. Please continue, sir.
Yeah. Now, see, we have discussed one important type of integration based on by parts. Now, I am taking a question based on it. Now, the question is integral e raised to power x tan inverse x plus 1 upon 1 plus x square dx, right? Now, here what I will do, this is the first function tan inverse x. This is the second function 1 upon 1 plus x square. If you are familiar with simple rules of differentiation, you know derivative of tan inverse x is 1 upon 1 plus x square. All of us know this. Now, what I told you, split this into two integrals. In the first, you write the function. In the second integral, you write its derivative. See, ex will be coming in both, right? In the first, fx is there, which is tan inverse x. In the second, you have the derivative of tan inverse x, which is 1 upon 1 plus x square, right? Now, इसको हमने split किया है into two integrals. What I have told you, हमने ये बताया था कि जिस इंटीग्रल में fx है, फंक्शन है, उसको by parts से expand कर दें. So I will not do any simplification in the second integral. This will come as it is. So the second integral will come as it is. The first integral I will expand by parts. Now how I will expand by parts? First function is tan inverse x. Integral of ex is ex minus integral. What is derivative of tan inverse x? Yeah, derivative of tan inverse x you know is 1 upon 1 plus x square. Integral second will come as it is. This is the second function. Its integral is ex only, right? Now you will realize again, as I told you in the formula, in proving the formula, that this second and these two integrals are exactly the same. One with positive sign, other with negative sign, and these two will cancel out. And what will be left? Ex tan inverse x plus c. And you know, little thinking will let you know the answer in the beginning also. Like if you have a function here and its derivative is being added, outside you have e raised to power x, the answer is always e raised to power x fx plus c. So I hope even checking the answer is easier for you. You know the final answer will be ex into fx. So the answer is ex into tan inverse x plus c. Now next is...
Sir, one of our viewer, Rifa Khanam, wants to know, are you going to explain differential calculus also? Sir?
Actually, you know, differential calculus is mainly divided into two parts. One is differential calculus and other is integral calculus. And now I am dealing with integral calculus.
Okay.
So here in integral calculus, after this I will be taking questions based on integration का जो definite integral है and then properties of definite integral. After that I will take application of integral. So differential calculus has been done earlier. I will be continuing with integration, and then we will take differential equation. Differential equation is also in calculus, but it is an application of integration. It is not differential calculus. It comes under integral calculus, but that I will do.
Okay,
Now, yeah. Now, students, just see, we have got more formulas here. Integration. See, if you want to be a master in integration, you have to remember all these concepts, all the formulas. Once you know these formulas, then by seeing the question, by observing the question, you can know what type it is. See, I consider that you will be perfect in integration. When a question comes to you, your mind will start thinking how to integrate it, what type it is, whether it is integration by parts, or it is integration by rational function, or it is some more types, or it is 6 special integrals. So these things are very important, and this you will master only when you practice a lot. So my advice is that you practice each and every exercise given in the book, and then all the examples also you thoroughly do, and then you will gain in confidence. So the next exercise is based on these 3 integrals. These are 3 more integrals. You know, in 6 special integrals in the last class, we discussed something similar to this. But in that case, all these integrals were coming in the denominator. They were 1 upon this. 1 upon square root of x square plus a square. 1 upon square root of a square minus x square. But here they are in the numerator. So these are the final results. I will prove one of them to show you how this is done. Right? So,
right, sir.
This is the first one. Integral of square root of x square minus a square dx is x by 2, x square minus a square root minus a square by 2 log of x plus square root of x square minus a square plus c. The second one, there is a difference, sign either minus or either plus ho jayega. The formula is similar, x by 2 integral of square root of x square plus a square by 2 log of x plus square root of x square plus a square plus c. And then this final third result is integral of square root of a square minus x square dx is equal to x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a plus c. Now, some of you might be thinking, sir, to direct formulas hi bata rahe hain. I will prove them. One of them I will prove. You can prove the others one on similarly you can prove the others. But these are very, very important. You can at times you can use these formulas directly also. So once you have proved them, you try and remember these formulas. Now I am taking a question which is based on the formula, the third formula which I have written, a square minus x square square root of a square minus x square. Now suppose you have to integrate this, and we want to go through the whole process of obtaining the solution. So what I will put is, I will put x is equal to 3 sine theta. Always remember one very important thing, if this type of question is there, you can substitute x equal to a secant theta. In this integral, x square plus a square root, you can substitute x is equal to a tan theta. And in the last one, when you have square root of a square minus x square, you can substitute x equal to a sine theta. So these substitutions will work for you. Now I am taking a question which is based on this third type, square root of a square minus x square. So as I just started, it is 3 square minus x square. Now I am substituting x is equal to 3 sine theta because x is a sine theta. And you know why these substitutions are made? These substitutions are made to get rid of the radical sign. If you substitute x equal to 3 sine theta, dx will be equal to 3 cos theta d theta. Now 3 square minus 3 square sine square theta, and this dx is replaced by 3 cos theta d theta. Then what you will get? 3 square 1 minus sine square theta will be cos square theta. See, this will come inside the radical sign. So there is this correction you can make here. This radical sign will come here, square root. So this 3 cos theta, right? This 3 cos theta multiplied by 3 cos theta, right? From here, if you simplify this, you will get 3 cos theta. Then you multiply again by 3 cos theta. Oh, yeah, this is the reason. After multiplying, it is correct. After multiplying, you are getting 3 square cos square theta, and then this becomes 9. And cos square theta you can write as 1 plus cos 2 theta by 2, and then 9 by 2 constant you can write outside. Integral of 1 is theta, and integral of cos 2 theta is sin 2 theta by 2 plus c. Right? Students, ये देखो बेटा integration we have already completed. This integration is over here. Now theta is sin inverse x by 3. Sin theta is x by 3. Theta is sin inverse x by 3. Right? And here again, as I have discussed earlier, how to substitute. This is 2 sin theta cos theta by 2. Only sin theta cos theta will be left. Substituting value of sin theta, which is x by 3, and cos theta, which is 1 minus sin square theta square root, I will obtain this answer. I hope when you will actually solve this question yourself, all these steps you will get. Right? Everything is in order, and actually, you know, here we were getting 3 cos theta, but again you have 3 cos theta outside. So product करके तो यही आए. So it is absolutely correct, and you can just solve and see whether your answer matches with this or not. I hope it is clear. Now, one more question I am taking of this. Square root integral of square root of x square plus 4x minus 5. Somebody. Right? Square root of x square plus 4x minus 5 dx. So what you will do here, you know, the question is based on the same concept, the same type. But one thing you have to remember, that you have to first convert it into x square minus a square or x square plus a square, or whatever form you will obtain. So here what you will do is, you have x square plus 4x minus 5. One very important concept of completing the squares, you know, you have already done in your earlier classes. But what we do, we write x square term, then we write the variable term 4x, then we take coefficient of x, which is 4, divide by 2, we'll get 2, 2 square I'll add and subtract. See why I have put this in a box, so that students are very clear with this idea. X square plus 4x minus 5 is written there. So plus 2 square minus 2 square, and you know this gives you x plus 2 whole square, and finally you will get minus 4 minus 5 minus 9, which is minus 3 square, and here I will substitute x plus 2 equal to 3 secant theta. I told you earlier, if it is x square minus a square form, you will put x plus 2 equal to a sec theta, dx is equal to 3 sec theta tan theta d theta, and on substituting here in this integral, you will realize it takes this shape, 9 tan square theta sec theta d theta. Right? Sec theta will come as it is, and what about tan square theta? Tan square theta you can write as sec square theta minus 1. See why I am telling you all these steps. Sometimes even if we get rid of this square root sign, उसके बाद भी हमें एक ऐसी फॉर्म आएगी which you cannot integrate straight away. तो tan square theta को हम लिखेंगे sec square theta minus 1, and I'll obtain two integrals. One is sec cube theta, another is sec theta. Sec cube theta and sec theta. So now I am substituting sec cube theta as I1. I am not able to integrate sec cube theta. So I1 I am substituting in place of integral of sec cube theta. Sec cube theta I will integrate separately, and whatever integral I will get, I will put it back here. So sec cube theta can be written as sec theta multiplied by sec square theta. You know, sec cube can be written as sec into sec square. Now this is one important question in which both are trigonometric, but I am taking sec square theta as second function because integral of sec square theta is easier. You know, integral of sec square theta is tan theta. So that is the reason I am taking sec square theta to be the second function instead of taking sec to be the second. Sec ka integral is log sec theta plus tan theta, and I want to avoid log. So I am applying by parts here. First function as it is, integral of sec square is tan theta minus integral, derivative of first is sec theta tan theta multiplied by tan theta, I will get tan square theta, and finally writing tan square as sec square theta minus 1, I will see I will get the same sec cube theta back. I am starting with sec cube. I have taught you this in the earlier question, ex sin x, ex cos x, all these questions, I get back the same integral. Here also I started with sec cube, and along the way I will get sec cube again. So integral of sec cube theta d theta is the same thing I started with. So I'll write it as I1, and then I'll get integral of sec theta, which is log of sec theta plus tan theta, and this I1 I'll transpose to the other side, and I'll obtain the integral of I1. And this is an important result. You can even remember this result, that integral of sec cube theta is this, right? Half of sec theta tan theta plus log of sec theta plus tan theta. And now this I1 which I have obtained, I'll substitute here. And I'll get the answer. This value of I1 I'll put back in equation 1. Now if you put it in equation 1, right, you will get this, right? So you know how this is looking a bit complicated, but what is happening? What was my substitution? See, starting में हमने I substituted sec theta equal to x by 2 by 3. See, from our substitution, sec theta is x by 2 divided by 3. So if you substitute sec theta as x by 2 by 3, tan square theta is square root of sec square theta minus 1. Again, sec theta is x plus 2 by 3. I'll substitute x plus 2 by 3 here, and tan square theta is square root of sec square theta minus 1. So I'll get this, right? So I am simplifying I1 further till it takes this shape, and this whole is the value of I1, which I substitute in the first equation, and finally simplifying this will be the result. So here, you know, we have tried to obtain the solution, the integral, by the method of substitution, showing all these steps. And if you think at some stage, you can even directly apply the formula and check whether you are getting the same answer or not. Now is the time to start definite integral. Right? I hope up till now it is clear to you. Any questions, ma'am, up to this stage?
Not yet, sir.
Acha. That means our students are following.
Sir, you are explaining us so wonderfully, sir.
Acha, ma'am. Now next part is our area function, definite integral. See, integral calculus is divided into two parts. एक तो इंटीग्रल होता है जिसमें कोई लिमिट्स नहीं होती. You know, these are the limits of integration. That integral is without any limits. That is known as indefinite integral. And then comes the definite integral. In definite integral, we have these limits of integration from a to b fx dx. Right? Now, definite integral का basic concept you have to understand. What is the difference between the two integrals? हैं तो दोनों integrals. When these limits comes, then it has a definite value. It will not be in algebraic form. The answer will be a definite constant. Now, a to b fx dx, I'll first define area function. A to b fx dx, where fx is greater than 0, is defined as the area of the region bounded by the curve y equal to fx, the ordinates x equal to a and x equal to b, and the x-axis. So, this basic thing you have to remember, that a to b integral a to b fx dx has some meaning. Some student asked me, sir, iska use kya hai? Area. To find out the area bounded below the curve, above the x-axis, in between the ordinates. Here, an important point you have to remember, that fx is positive.
सर यहाँ पर मैं आपसे जानना चाहूँगी, क्या इंटीग्रेशन हमेशा एरिया को रिप्रेजेंट करता है?
It gives you the area if the curve is above the x-axis. See, here it is mentioned fx is positive because if this function is positive, then this curve will lie above the x-axis, and then it will give you the area. Sometimes, you know, the curve can be below the x-axis, then it will give you the signed area. Its modulus will give you the area. The value of the integral will come out to be negative if the curve is below the x-axis, and if it is above the x-axis, you will get the exact area because it will be positive. So, very good question, whosoever has asked. So, therefore, I mentioned fx is positive, gives you the area. A to b, integral a to b fx dx gives you the area between x equal to a and x equal to b and below this curve. Now, if x is any point between a and b, x is some point somewhere in between, in this interval, closed interval, it can be even, it can coincide with a and b, but generally we take x somewhere in between these 2 points. Then a to b fx dx gives you the total area. But if we write a to x, if we want this area, this shaded area, then our lower limit will be a, then the upper limit will become x. In place of b, if I write x here, in place of b, if I write x here, then I'll get this area. If this x moves further away, suppose value of x is incremented, it comes here, then we'll get this area. This area will get. So when x will change, our area will change, and that is known as the area function. Now, before we further continue with our definite integral, there are 2 very important theorems. These are known as fundamental theorem of integral calculus, and they are very, very important to understand. Let f be a first fundamental theorem of integral calculus. Let f be a continuous function on a closed interval ab, and let ax be the area function. Then a dash x is equal to fx for all x belonging to the interval, closed interval ab. This is our first fundamental theorem of integral calculus. You have to just understand this theorem. And second fundamental theorem of integral calculus is, let f be a continuous function defined on the closed interval ab, and let capital F be the antiderivative of f. Antiderivative means integral. Then a to b fx dx is equal to integral of fx is capital F. But when these limits are there, I'll write the limits a and b here, and then further I'll simplify it. It will be upper limit minus lower limit. So whatever is the function, first I'll substitute upper limit in place of x. I'll get fb, and then I'll subtract the lower limit. That means I'll subtract the function, the value of the function, when I substitute the lower limit in place of x. So what I'm trying to explain by second fundamental theorem of integral calculus is that if the integral is a to b fx dx, and integral of small f is capital F, that means the antiderivative. So I'll first integrate it. So whatever rules you have learned for indefinite integral up till now, you integrate this function, and later on you put upper limit minus lower limit in the function. That will give you the value of the definite integral. I hope these two theorems are clear to you. These are very important theorems, and on this will be based our next part, which is our definite integral. Now I am taking some examples based on the result which I have just told you. All of you know integral of x square is x cubed by 3. It's the simplest of results. Then these limits you will write here. Later on, this is 1 by 3. X cubed will be 3 cubed minus, and one more thing I would like to tell you here is, if there is a multiplicative constant here, it can be taken outside before putting the limits. This 3 is a multiplicative constant, you can write outside. So x cube may, if I put 3, I'll get 3 cube minus 2 cube. On simplifying this, I'll get 19 by 3. Now another question based on definite integral. Integral of 2 to 3 1 by x dx. We know integral of 1 by x, here equality sign should be there in between. You can substitute equal to here. Integral of 1 by x is log x. Now log x, if you put the limits as 2 to 3, will be log 3 minus log 2. And students, you must be knowing these properties of log. Log a minus log b is log a by b. So log 3 by 2 is the right answer. And finally, one more integral 0 to 1, 1 upon x square dx. So integral of 1 upon 1 plus x square, 1 upon 1 plus x square, you know, is tan inverse x. You put these limits, tan inverse 1 minus tan inverse 0, and you get pi by 4 as the answer. So these are very elementary, simple questions which we have discussed here. Now, continuing with definite integral, let us take this one. Integral 0 to 1 sine inverse 2x upon 1 plus x square dx. Now here, you know, in the beginning only, we are at a dead end, you can say, कि what to do. Now, directly तो कुछ समझ नहीं आ रहा है. So what we do is, we make a substitution. I'll put x is equal to tan theta. Why I'm substituting x equal to tan theta? Because if I substitute x equal to tan theta in this, I'll get sin 2 theta. 2 tan theta upon 1 plus tan square theta is sin 2 theta. And you know, but here what I want to tell you is, what I want to explain you is that if you substitute x is equal to tan theta here, our limits will also change. Whenever you make a substitution, the limits will also change. So when I am putting x is equal to tan theta, you know dx is sec square theta d theta. When x is 1, I'll put x equal to 1. So tan theta will be equal to 1, theta will be equal to pi by 4. And when I substitute x equal to 0, जहां पर भी substitution किया है, उस equation में you put x equal to 0. If you put x equal to 0, when is tan theta 0? All of us know tan theta is 0 when theta is 0. So the limits will change from 0 to 1 to 0 to pi by 4. So our new integral will be integral 0 to pi by 4 sine inverse, and here I am substituting x equal to tan theta, and derivative is sec square theta dx will be equal to sec square theta d theta. As I told you, these formulas you have to remember. This is sine 2 theta, and sine inverse sine 2 theta will give you 2 theta. So eventually you will get 2 theta sec square theta d theta. So integral of 2 theta sec square theta. 2 I can take outside, 2 theta sec square theta d theta. And now here again I am applying by parts. Now you are familiar with how to apply by parts. First function as it is, integral of second is tan theta minus integral, derivative of first is 1, integral of second which is sec square theta I have written here, the same thing will come here, integral of second, and then simplifying this I obtain this. Now once you have obtained this, these limits you have to put. First I will put pi by 4 in this, and then minus I will put the lower limit 0. Now see carefully, if I put pi by 4 I will get pi by 4, tan pi by 4 is 1, log of, what is cos pi by 4? Cos pi by 4 is 1 by root 2, and then when I subtract 0 the whole thing will go, because 0 into tan 0 both are zeros, and if I put 0 here, cos 0 is 1, but log 1 is 0. So you can just see, mathematics you will learn only when you will solve this question yourself. You keep a notebook ready with a pen or a pencil and try and go through all these steps and things will fall in place. सब समझ आने लग जाएगा. But ये सब formulas, ये trigonometric values, that log 1 is 0, cos 0 is 1, all these things you have to remember. तो वो practice करिए अपना, and these formulas you will remember, and finally you will get pi by 2 minus log 2.
Right. So let me tell our viewers that we are still having so many minutes. We are in the last 15 minutes of this session. If you have any query, feel free to connect to us. You can drop a comment at our email. You can either mail us, and you can even drop a comment at our YouTube channel, that is NCRT Official. Go to the live chat box and drop your comment out there. We would be happy to have only relevant questions out there. So please continue, sir.
Yeah, see, students, you can ask any question related to integral, definite
yes,
integral, indefinite integral. So, and if they are connected to what I am discussing here, it will be better. So your question will help thousands of other students to understand these concepts. So if you have any doubt, feel free to ask, and ma'am will convey that question to me. She will tell me that this is the doubt, and I'll answer there and then.
Exactly. Last quarters of the hour, हम अभी अपने आखिरी 15 मिनट में हैं. आप जितनी भी queries आपके पास हैं, आप हमें बता सकते हैं. Yes, sir. Please continue, sir.
Yeah. Now comes some properties of definite integral. Now the first property is a to b fx dx is a to b ft dt. देखिए definite integral में, because the answer is a constant, तो हम variable will have no effect. If I'll give an example to make you understand this. If you are integrating 0 to 1 x square dx, or you are integrating 0 to 1 y square dy, or you are integrating 0 to 1 t square dt, answer will come out to be the same. So if suppose you are integrating 0 to pi by 2 cos x dx, in place of that you can integrate 0 to pi by 2 in place of cos x dx, you can write cos y dy, you can write cos t dt. If this function is same, just changing the variable will not give you a different answer. Your answer will be exactly the same. This is the first property. Second property is, if you interchange these limits, the sign will change. Because you know, if you finally, when you substitute, suppose integral of small f is capital F, you will get fb minus fa here, and here you will get capital Fa minus capital Fb. But then what's the difference? The difference will be just of sign. Third is, a to b fx dx will be 0 if a and b are equal. Here, in fact, you can write a and b fx dx is 0 if a and b are equal. Because you know, if the two limits coincide, here in place of b you can write a, in place of b you can write a to a, then will be 0. Here b 0 nahi hai. This will be 0 if a is equal to b. Now, next is another property, this is the fourth property, that a to b fx dx. A to b fx dx is a to alpha plus alpha to b. Because you know, a to alpha is this part and alpha to b is this part. So you can split it into two parts. This is alpha. This particular thing is alpha. So I think it is printed as infinity. It should be alpha. So a to b fx dx is a to alpha. This is a to alpha. This take as alpha, and then alpha to b. So this whole integral a to b fx dx is this integral plus then this integral. Integral from a to alpha will give you this area, and area further integral from alpha to b will give you this area. So this total area is nothing but equal to this area plus this area. Now I'll solve some questions based on these properties. I've discussed some properties. Now let us solve this integral 2 to 8 mod of x minus 5 dx. Now see, if you equate this x minus 5 equal to 0, you will get x equal to 5. If you draw the graph of this mod function, the graph will be like this. It is V-shaped, and at x equal to 5, the value of the function is 0. So I'll split this into two parts, 2 to 5 and then 5 to 8. Because you know, integral is always positive. When you take any value of x between 5 to 8, this expression will be positive. So its mod will be x minus 5. And when you take any value between 2 and 5, the value of mod x minus 5 will be negative. So it will be minus of x minus 5. So basically, mod of a number is equal to that same quantity if that expression is positive. And it is equal to negative of itself when the expression, the value of this will be negative. You take any number between 2 and 5. Let us take 3. So what is 3 minus 5? Minus 2. It is negative. So its mod will be minus of this. And then you can just integrate them separately and obtain the answer. Another way to solve this same question is, I can make a substitution x minus 5 equal to t, so that dx is equal to dt, and then I have told you just in the previous question, whenever you make a substitution, change the limits, because now we have a new variable. If I put x equal to 2 here, 2 minus 5 is minus 3. If I take the upper limit 8, if I put 8 here, 8 minus 5 is 3. So our integral is minus 3 to 3 mod t dt. So minus 3 to 0 t dt plus 0 to 3 t dt. So I am just splitting it in between. I told you that if its limit is from minus 3 to 3, I can write from minus 3 to 0 and 0 to 3. Because in minus 3 to 0 it will be minus t because t is negative, and 0 to 3 it will be t because t is positive, and then I can just integrate them separately and obtain the answer. Now I will take another question. Integral of 0 to pi mod cos x dx. Right? I hope I can take one or two more questions.
Yes sir, exactly हमारे पास last के 5 मिनट बचे हैं.
Yeah.
We have 5 more minutes to left, sir.
Yeah. So I'll take this question again. It is based on the same concept that 0 to pi mod cos x dx. Now here what I'll do is, now you know that these are 4 quadrants, 1, 2, 3, 4, and cos x is positive in the first quadrant. In fact, every t ratio is positive in the first quadrant. All t ratios are positive. And in the second quadrant, cos थीटा तो नेगेटिव होता है, साइन पॉजिटिव होता है, cosec पॉजिटिव होता है, बट द अदर्स cos and sec are negative in the second. So we have to just concentrate on the sign of cos x. In the first quadrant, 0 to pi by 2, all t ratios are positive, so cos is positive. So 0 to pi by 2 में mod cos x will be cos x only because cos theta is positive. In the second quadrant, cos theta is negative. Therefore, because since cos x is taking a negative value and x varies from pi by 2 to pi, therefore its mod is minus of cos x. बेटा ये माइनस कहाँ से आया है? ये cos x, mod cos x is minus cos x. So this cos x, this minus comes as it is. Now you integrate either cos x का integral sin x, either cos x का integral sin x, and then you write upper limit minus lower limit, and finally you get this. And solving this, you will get 2 as answer. I hope this question is also clear to you. This is based on the same concept as this algebraic one. Both of them are based on the same concept. Now, another last property which I would like to discuss today is that a to b fx dx is equal to a to b f of a plus b minus x dx. Now, what is happening here? I have a definite integral. The limits are a to b fx dx. In place of x, if x is replaced by a plus b minus x, the value of the definite integral will remain unchanged. The value of the integral will remain same. So the property is simple, that in place of x you write lower limit plus upper limit minus x, the value remains same. And for a change I have tried to prove it also. The proofs are very simple. You start with right hand side, f of a plus b minus x dx. Now I am substituting a plus b minus x is equal to t. So minus dx is dt. Now when I substitute here, I will get ft minus dt, and the limits will interchange, right? And finally I will get a to b fx dx. And as a special case of this, if the lower limit is 0, 0 to a fx dx will be 0 to a f of upper limit minus x dx. I hope these two are clear to you. I'll just solve one question based on it. Let us take this question, 0 to pi by 2 cos 3 by 2x upon sin x raised to power 3 by 2 plus cos x raised to power 3 by 2 dx. So what I will do is, in place of x, I will write upper limit minus x everywhere. Wherever in the integral, wherever x is coming, I will write pi by 2 minus x. This cos of pi by 2 minus x is sin x. So I get sin x raised to power 3 by 2. This sin will become cos, and this cos will become sin. And if you look at these two, if I am adding integral 1 and 2, I will get 2i, because this is also I, this is also I. On adding them, I will get 2i. It is equal to, when I will add these two, I will get sin x raised to power 3 by 2 plus cos x raised to power 3 by 2 upon the same thing. So that will cancel out and I will get 1. I will get 1. So 1 ka integral you know is x, and then the limits are 0 to pi by 2. I will get 2i is equal to pi by 2 and I equal to pi by 4. I hope you have understood this, and if you have any queries here, because I don't think we have much time for other questions. If you have any query here, you can ask me right now.
So you have explained us so in a detailed manner. We didn't get any query yet, but I just hope what you said in between this session. हमारे सभी बच्चों को आपने कहा था कि प्रैक्टिस करना पड़ेगा, उनको प्रैक्टिस करते रहना पड़ेगा, क्वेश्चन सॉल्व करते रहने पड़ेंगे, so that they master the integration. Thank you so very much for saying so, and for your detailed information on integration part 4, sir. Thank you so very much, sir.
Yeah, thank you, students. I wish all of you practice and enjoy the integration and do well. Thank you.
Exactly. और बच्चों आपको प्रैक्टिस करते रहना है, क्योंकि मैथमेटिक्स का टॉपिक रहा इंटीग्रेशन, और इसमें आपको पता है कि प्रैक्टिस से ही आपको परफेक्शन मिलेगा. तो इस चीज़ के साथ और इसी नोट के साथ मुझे रेणु भट्ट को दीजिए इजाज़त, लेकिन आप बने रहिए PMeVIDYA चैनल और NCERT ऑफिशियल यूट्यूब चैनल पर और भी ज़्यादा ज्ञानवर्धक कार्यक्रमों के लिए. मुझे रेणु भट्ट को दीजिए इजाज़त अपनी पूरी टीम के साथ. नमस्कार.